So we'll kick this off then, because we're running 5 minutes over time as it is. So this presentation is called Testing the Moon, a Globe-Lie Perspective. First, a quick message from Brian Cox. Perhaps they would put this quote below: everyone attending this conference is a shitbox. That's what Brian Cox thinks of things like conferences and conventions. Now a quick message.
There is absolutely no basis at all for thinking the world is flat. Nobody in human history, as far as I know, has thought the world was flat.
Nobody in human history? How about every single ancient civilization in history? You've got the Mayans, the Norse, the Hindus, the Incas, the Navajo, even the Egyptians. I mean, the Egyptian cosmology doesn't exactly look like a spinning ball in outer space, does it? So, proof of the globe. This is actually taken from the BBC, and this is one of their images taken from their actual video, proof of the globe. So, one of the biggest proofs is that boats sail over the curvature of the Earth. When you learn about the true law of perspective, what happens is the center of the object becomes that datum point. So when the object moves away from you, it obviously gets smaller, and that's how it comes to a vanishing point. But when you're on the ocean, something else happens. The actual ocean becomes a datum line. So as an object sails away from you, as you can see, it converges into a little point. That's where it looks like that the actual boat is sailing over the curvature of the Earth. This is an interesting video I got from Brighton this year. This is basically just the camera facing at the sun, setting over the ocean. I've actually cut the sound from this, but this is a very, very interesting sunset. And as you can see, whoosh, the sun disappears in a puff of green smoke. What seemed like a puff of green smoke. So you saw this on Rob's presentation earlier on today, but it is a brilliant quote. Today's scientists have substituted mathematics for experiments, and they wander off through equation after equation and eventually build a structure which has no relation to reality. So basically what he's saying there is everything is theoretical going forwards these days. This is a 11.5-hour time lapse of Polaris. What you'll notice is, over that time period, there's only one concentric motion. What's not apparent in this actual observation is that the Earth has apparently moved half a degree around the sun. So, in the heliocentric eyes, it's actually travelled 32,000 miles from that position. But all we ever see is that one concentric motion. You never see that shift where it actually moves along the ecliptic, which it just proves to me that we're stationary and it's everything else that turns around. So the only experiment to try and prove that the Earth moves along the ecliptic was the Michelson-Morley experiment. So I'll just read this out. It says, Professor Michelson was one of the physicists foremost in determining the velocity of light. While he has recently been described in the New York Times as America's greatest physicist, and it was he who, working in collaboration with Morley in 1887, made the most painstaking experiments by means of rays of light for the purpose of testing, verifying, and providing by physical science what really was the velocity of the Earth. And as you know, they couldn't detect no motion. So on the back of that, Albert Einstein built up his theory of relativity. So they had the choice, yeah, the Earth's stationary, yeah, or it's everything else. So they went for the theory side to it, obviously to keep the agenda going. So, I don't know if anybody's ever seen the Nikon Coolpix P1000, aka the Curve Buster. Back in February of this year, I'd made an observation with Dr. John Dee if anybody's ever known of him. If you just search his channel, you'll find his stuff. He does a lot of stuff from the peer-to-peer. Basically, he lives in Worthing, and he's done a lot of laser experiments between Worthing and Brighton, which is approximately 9.5 miles. So I was at one of these observations back in February. So the distance is 9.5 miles, and there you can see you've got Brighton and Worthing. So the direction. We was on the south coast, and obviously I was facing in a westerly direction, 278 degrees, and you can actually see just a green dot from the laser from the opposite pier. This is Dr. John and his team setting up at Worthing Pier. And this is myself, Roxanne Glenn, and a few others setting up at Brighton Pier. This is just a quick zoom I did of Worthing, and immediately what I noticed was there wasn't a lot of refraction. We've done this observation a number of times, and when the conditions aren't right, you can't see anything. But what we noticed on that day is that the conditions were right to make the observation. So we took various readings. We took the temperature of the water. We took humidity readings. There you go. We took the water temperature, which was approximately 7 degrees. There you can see we took the temperature at 1 meter, which is 3.2 feet. We took various readings again. We actually took the readings as we went up through the different heights to get the refraction index and get the temperatures between. And we also took the laser height as well. And as you can see, from Worthing to Brighton, if you look in the distance of the horizon, you'll see a red spot. That's the laser from the opposite pier shining towards Dr. John Dee's team. And if you look at the laser shot we took between Brighton and Worthing, what you'll see, people say, oh yeah, that laser looks pretty spectacular. But what is spectacular is that green dot. Yeah, that's the most spectacular thing. That green dot shouldn't be able to be seen from that distance. And there's another close-up of it, and you can see the green dot again. This is just a little video, what we shot. And at this moment in time, what we did, the tide was coming in, so we decided to take the laser down to 6 inches above sea level. Even at 6 inches down, we could still see the laser light source from the opposite pier. Now, the likelihood of seeing that on a globe was actually 1%. So, what did the Midwest Metabunk calculator say about that? So we pumped in all the distance, 9.5 miles. The viewer height was 3.2 feet, and the distance was 9.5 miles. And the results, if you ignore the refraction, there should have been a hidden of 35 feet worth of hidden curvature, which wasn't present. Now, if you look at the standard refraction, when it's calculated in, there should still be at least 28 feet of curvature between them 2 points with a standard refraction. But what I noticed recently is, I went back to the Metabunk calculator to try and redo these numbers again, and Midwest has added a little extra line into the calculator. It now says, note, accurate for observations over water, sorry, not accurate for observations over water very close to the horizon. So what he's doing basically is trying to move the goalposts again. Yeah, first time he had the calculator, you beat the observation. Yeah, he brings in a new calculator with a refraction in it, you beat that, and now he's saying we can't go over water to make these observations. Yeah, so it's just moving the goalposts each time. So my question was, behind what curve? Clearly, there's no measurable curvature there. I'm sure you've all seen this one.
I was going to get anything that would beat this until I found this photo, Ranmere State Park. This is from Joshua Nowicki, and what you're seeing here is a mirage.
So, what you're seeing is a mirage. I'm sure you've seen this one as well over Lake Pontchartrain, where this is their proof of curvature, and as you can see, the light is actually bending downwards. We know that the light bends downwards. But what is apparent, the horizon is always at your eye level. So whether you're at the beach, whether you're on Mount Everest, or whether you're 120,000 feet in a weather balloon, the horizon is always at your eye level. The only time you do see curvature is on things like the Felix Baumgartner space jump. And as you can see there, you notice how the horizon line now is actually high up, yeah? Because the center of the image is where you get your true representation of your horizon. When that camera is tilted down, then we'll get the convex image. And like we've seen on previous presentations, when you tilt it the other way, you get a concave image. But you get a true representation when the horizon is equidistant. But that don't matter anyway, because...
And not only that, they made sure to photograph him standing there with a really wide-angle lens, which curves horizontal lines. So in the photo, you see this curvature of Earth's surface, and he said, wow, he's in space. Look at that. No, he's not. At that height, you don't see the curvature of the Earth if you are 2 millimeters above this beach ball. You just don't. That stuff is flat.
Neil's own words, that stuff is flat. So that got me thinking, how high do we need to go to start to see the curvature? Now, I searched the internet for weeks and weeks and weeks, and the only footage I could find was the GoPro awards with the SL-10 amateur rocket. Now, that reached an altitude of 396,000 feet. That's nearly 70 miles up. And what you'll notice is when you get the camera equidistance in the center of the frame, you get the true representation of the horizon. And as you can see, even at 70 miles up, and remember, that's a GoPro lens, which gives you an 180 degrees view of the horizon, and guess what? It's still flat. So how high do we need to go up to see the curvature? We've seen this a number of times. I'm not going to spend a lot of time on this, but when you search for images of Earth, you just get a lot of cartoons, basically. And we know this guy, Mr. Blue Marble, Rob Simon.
It is photoshopped, but it has to be.
Recently, I was looking into the Parker Solar Probe, and they took a beautiful shot of the Earth and the Moon from 27 million miles out. My question is, why didn't they take a shot of the Earth when they was 125,000 miles out? Yeah? It would have been the perfect opportunity to get the perfect shot of Earth. Not only that, they apparently did a flyby of Venus, yeah? And we've got no images of that either. But that is the actual image that they sent back. That's supposed to be Earth from 27 million miles away. Rob Simon would probably say it is Photoshop, because it has to be. So, what are we told? We're told that we live on a globe, and we're told we're orbited by a single satellite, which we call the Moon. Now, the Moon, what I'm going to touch on in this presentation is the actual point, the closest point to the Moon and the furthest point to the Moon. The closest point being perigee and the furthest point being apogee. I'm going to be looking at that in a little while. But from what I've actually observed myself over the last 3 years, yeah, it doesn't fit any of this model whatsoever. There's no measurable curvature, the horizon always rises to the eye level, and it's always flat. So we have to start looking at the Moon from a different perspective. So, testing the Moon. My observations, I've just used some very, very basic tools when I make my observations. I have a compass. I use the Nikon Coolpix B700 camera, which I've had that camera almost nearly 3 years now. I've also now upgraded to the Nikon Coolpix P1000. I also use an app. I don't know if you see Rob Skiba's presentation earlier on today when he was talking about the Theodolite app. Well, this is the Android version. This one's free, yeah? So if you've got an Android phone, you can have this one free. So what is Dioptra Camera Tool? Basically, it's a camera position and angle measurement tool for navigation, surveying, positioning, and measurements. Yeah, it provides the following information like a theodolite. So you've got your yawn, basically you've got your compass, whatever direction you're facing, your pitch, so you've got your tilt, and also, you've also got your roll as well. So it's quite an handy tool, and it also takes an azimuth and bearing to photo shot. So when you point at an object, you take a shot, it'll give you a direction, and it'll also give you an angle from the horizon. So this is just a shot I took of the Moon. Yes, I'm sometimes up very early, as you can see, it's 4:24. But what I wanted to just give you a demonstration is how I actually measured the Moon. Here, what I've done, I've just took NASA's moon phases and I just compared to see if, yeah, you know what, I've got the right phase there. And as you can see, the moon appears to be at its furthest point at apogee, but we'll get into that in a bit. I also took a diopter reading. So what I do, I point the app at the moon. It gives me a direction, which is 180 degrees. What I found out is, if you want to make accurate observations, you've got to be consistent. So I try to make most of my observations at 180 degrees, which is my meridian, or my zenith. I also compared that with mooncalc, because it'd be a bit silly if I went out there and I took a shot at 180 degrees, and when I look on mooncalc, it says I'm 275 degrees west. So all I'm doing here is verifying my observations. And as you can see, my azimuth, or my direction, 178 degrees, with a declination angle of 38. Mooncalc says 179 degrees, a little bit out, half a degree, and the moon altitude is 38 degrees, which is very similar. So my observations I'm making are pretty accurate. And here's just a quick demonstration on how I actually measured the moon. I used a tool called Bearsoft measuring tool. And what this does, you can measure anything with this. If you've got the numbers, you can pump in anything and measure anything basically. You measure streets, but I just use it for measuring the actual moon. You can measure the radius, you can measure the circumference, you can even measure the inside, the craters if you want. It's very, very, very good software. So simply all I'm doing here, just measuring the radius to see what the length of the moon is. It's not 100% accurate. This is just for a demonstration, but we'll get to the more accurate readings later on. And as you can see, it gives you a pixel count of 2,345 pixels. All I do then is actually compress that image so the actual figures are embedded into the actual image. And as you can see, that's the finished product there. So that's how I measured the moon. So, the moon illusion. I know Rob Skiba touched on this, and I've got a different theory to what he came out with, because he mentioned that when the moon appears huge on the horizon, it's due to atmospheric lensing. Now, I've measured the moon on the horizon to the zenith 15, 16 times, and you get the same results every time, but we'll look at that. So, when I measured the moon on the horizon, as you can see, I measured the width and the height of the moon. Mainstream will claim there is a little bit of atmospheric compression, which I'll accept that. So the width of the moon on the horizon was 2,011 pixels, and the height was 1,860 pixels. What I did as well, something that NASA can't do, I actually took the metadata from the image. The most important thing is, if you look in the top left-hand side, and you'll see the lens, and you'll see the focal length, which is 258 millimeters. Yeah, basically, it's the full optical zoom on the Nikon Coolpix B700, which is approximately 60 times zoom. So, always use the same focal point. And here, I took a snapshot from mooncalc to show you that the moon is on the horizon. There's a couple of interesting factors here, what we'll look at in a minute. But if you look at the actual moon distance, which is 1, 2, 3, 4, fourth down, I'll just show you here. The fourth one down, it's got the blue writing blue background next to it. You'll see the distance in kilometers. It's 369,000 kilometers, so they say. Not only that, you'll notice that the moon is actually 99.7% full. So then what I did, I waited for the moon, got to my zenith, which I mentioned is 180 degrees south. And what you'll notice straight away is it's got bigger. Quite a lot bigger as well. So if you look at the pixel count now, it's 2,048 pixels across, and it's got a height of 2,051. Again, something NASA won't do. I've got the metadata to show, yes, the image is at 258 millimeter focal length, so I'm keeping it very consistent. And I also took a snapshot of mooncalc to show that the moon is at my zenith, which is 180 degrees. What you'll notice now, though, if you look at the distance now, it's actually 700 miles further away between my first observation and the observation at zenith. Because of the heliocentric model, the moon is actually heading towards its furthest point at apogee. So it's actually 700 miles further away from me between the two observations. Not only that, the moon is waning as well. So now it's at 99.4%. So it's getting smaller. But what I noticed is, it gets bigger at zenith. So when you see this huge moon on the horizon, it actually measures smaller than that tiny little moon you can see in open space. Yeah? I know that mainstream do claim there's a slight bit of compression, but if you look at the actual pixel width, you'll see it's 2011 pixels, and if you look at it on the zenith one, it's 2048. So it's actually got bigger. Now, in my eyes, the only reason why that moon could get bigger is if it's a lot closer than mainstream are depicting. There's no way you'd get that much change in angular size. Remember, the moon's heading towards apogee in their model. It should be getting smaller as it's coming to my zenith. It's 700 miles further away, and it's waned. But what you'll see, it's actually getting bigger. Now, that's not the first time I've done this observation. I've done this observation a lot of times, and you get the same results every single time. So what did NASA say? They say, step outside any evening at sunset and look around. You'll see a giant moon rising in the east. Sounds like a 4-year-old, doesn't it? It looks like the Earth's moon, round and cratered. The man in the moon is in his usual place, but something's wrong. A full moon is strangely inflated. It's huge. Now, that's a single frame shot from the night I made the observation. And as you can see, there is a kind of illusion there. You know what I mean? The moon does look big, and it does look actually big with the eyes. And also, NASA claim, if you want to measure the moon, get your finger, stick it in front of the moon on the horizon, then wait till it's at zenith and measure it again. It's 2019, and they're asking us to measure the moon with his index finger. Yeah? You know what I mean? We've got the tools to make these observations, and that's what I'm doing. I'm using these tools. So what we perceive is the moon looks huge on the horizon, yeah, and it looks small above. But what I've showed you, there is an optical illusion there, and I don't know if you've heard of the Ponzo illusion. As you can see, the two horizontal lines, they're exactly the same size. Yeah? So when the moon is on the horizon, you can actually relate to it against the background. When it's in open space, there's nothing you can relate it with. So there is an illusion there. But the main factor is, when you put these results side by side, as you can see, the moon distance on rise was 369,000 miles, and when the moon was at my zenith, it was 370,000 miles. It was actually 99.7% full when it was on the horizon, and it was 99.4. So in reality, or according to the heliocentric model, it should have got smaller. But like I've showed you before, it always gets bigger. So we'll try that again. This is a very similar observation. But what I've done it over the hour. So you'll see my first observation, the width 2108, height 2056. Next observation, width 2110, height 2099, so it's getting slightly bigger. Width 2127, height 2131, it's getting bigger again. 2150, 2148, it's getting bigger again. 2157, 2156, it's getting even bigger. So as it's approaching my zenith, it's actually getting bigger. The only way that could happen is if it's a lot closer than mainstream depict. But what was interesting is that rotation. Now, there's been a lot of theories on this. I actually put a video out 3 years ago, and I got it completely wrong. So I spent quite a lot of time on the rotation of the moon. But as you can see there, you've got all the measurements, and the moon actually gets bigger as it approaches the zenith. It's not a one-off. Yeah, I've done this lots and lots of times, always with the same results. So, the moon rotation. Why is the moon rotating? A lot of people have asked me this question, and this is my answer. First thing you're going to need for a moon rotation is a DIY moon rotation kit. So basically, 4 A4 pieces of paper, 4 shots of the moon, pair of scissors, and some blue tape. What I did, I stuck them on my ceiling. Not only did I stick them on my ceiling, I calibrated the app so the meridian line was my 180. So I've got the center of the room as my meridian line. Then what I did, put my camera in position, and I had the diopter app as well. and I faced east. And what I noticed as I moved the camera from east to west, the moon rotated. Can you see that in the image? So the moon's not actually rotating, the perspective is changing. Now when we zoom in on that moon close up, what you'll see again, you'll see the moon rotates. All I'm going is going from east to west in a straight line, and the moon appears to rotate. Have you noticed as well that there's a change in size, angular size of the moon? If you look at the actual size, you'll see it gets bigger as it gets close to the zenith, then smaller as it leaves the zenith. What I did as well, I took my observation from outside, and I took my observation from inside, and I put them side by side. The one outside was at 51.7 degrees declination angle, the one inside was 51.6. The one in the west, 55.5 for the outdoor one, and 53.5. But what you'll notice is, you get nearly the exact same amount of rotation. So for me, it's not the moon that's rotating, it's the angle what's changing. So as you move your camera, and it moves along, yeah, the actual camera is rotating the opposite direction, which gives the impression that the moon is rotating clockwise. This is another, we've seen this when you see the moon from Australia and it appears upside down. That again, just the perspective's changed. They call that crazy. That's called crazy. But that's pretty normal. I know Rob Skiba had this in his presentation earlier on, but you need some kind of magical force to stick yourself to the bottom of that ball. Hello, Mr. Blue Sky. Now, there's been a lot of questions asked about, can you see stars through the moon? Why do you see blue sky through the moon? I've been observing the moon for 4 years, and I've never seen a star through the moon, ever. I actually took this off Zavonier's webpage, Eric Debay. And this is straight off the IFA's webpage, and what he did, he told us that somebody caught Venus in a crescent moon. Now, like I say, I've been observing the moon for almost 4 years, and I've never seen this. I've filmed 2 stars go behind the moon on 2 separate occasions, and it didn't pop out until it cleared the whole disk of the moon, even when it was a quarter moon. So, also, if you look at mountains from a distance, they look translucent. I actually took that shot when I was in the Canary Islands, and if you look, you think, they do actually look quite see-through. You get a similar kind of effect with the moon because of the way that the light scatters. But what you will see, if you can get the right settings on your camera, you will actually be able to light up the dark side of the moon, so you can actually see, yeah, the whole disk of the moon is always present, always, yeah. When it's close to the sun, you're going to have a lot of light, which is going to be very difficult to actually see the shadow part of the moon. But what I did here, I took a daytime shot, and I just showed you, if you just change the settings on some kind of software, you can change it into a nighttime shot, just by changing the settings. So, here you have the light spectrum, and as you can see, you have shortwave light, which is the ultraviolet light, and you have long-wave light. Now, we know that the white light scatters easier, yeah, and that's why they say the sky is blue. But also, the reason why you see a red moon is because that long-wave light can penetrate the denser layers of atmosphere, which the ultraviolet waves can't. So what you see, you'll only see the red come through. That's why the moon appears red when it's on the horizon. Same with the sun as well, and most celestial objects. So these are a few of the lunar cycles, what I've tried to test out, yeah. So what I thought I'd do, the easiest one for me to test out would be what you call the anomalistic cycle. Basically, that's the time it takes the moon to get from apogee to perigee and back again. So it's related to the eccentricity of the moon. What I did on 23rd of the 8th, 2018, I took a shot of the moon. Always take a shot of the moon when it's at my zenith to keep my observations consistent. I also took a diopter reading, as you can see, 180 degrees. I also took a moon calc reading to see if my observations are accurate. I also looked at NASA's model to see, yeah, you know what, NASA are also telling us that the moon is at apogee as well, the furthest point in its cycle. Then I found out when the moon was at perigee, and I repeated the observation. So there you can see on the 24th of the 12th, 2018, took a shot of the moon. Again, 180 degrees facing south. The moon was quite high, at 58 degrees. Again, took a moon count reading to just always to make sure my observations are accurate. Some people say using globe math, but I'm just using it simply for a direction and a declination angle. That's all. Then again, back onto NASA's model, and as you can see, according to their model, it's at perigee. And then I actually measured the image. What I did as well, I put the images side by side, always at the same focal length. What you can see, yes, there is a measurable difference. So clearly, there is a point of apogee and a point of perigee. And if you're ever going to be building a flat Earth model, these things are going to need to be taken into consideration when putting models together. And just like anybody else, I repeated the observation just to make sure I got it right first time. So again, when the moon's at apogee, always at 180 degrees, keep the observations consistent. Took a moon count reading. Interestingly, I was in the Canary Islands when I took this one. There again, you can see, according to NASA's model, the moon's at its furthest point at apogee. Took a measurement, 1808 pixels. Then on the 25th of 11th, 2018, took another shot of the moon when it's at perigee. Again, another reading at 180 degrees. And a declination angle, pretty high again, 56.7. What you'll find is it follows a pretty similar cycle. So whatever position the moon is at apogee, 4 years later, it's in that exact same point in the anomalistic cycle. And it changes every 2 years from apogee to perigee. It literally falls perfectly into the 4-year calendar. Then another quick screenshot from MoonCalc. A look at NASA's model. What you'll notice about the apogee and perigee, it doesn't always get to the same point in the cycle each month. It changes. There's a slight variation in the distances. Then again, I took another shot there and then put them side by side. And there again, from the second observation, there is clearly a point of apogee and perigee within the cycle. And this is a micromoon and a supermoon. As you can see, there's quite a significant change in size. I think it's around about 8% change. So back to the lunar cycles. So I've tested the anomalistic cycle, and I can put a tick next to that box. Yeah, but back in July 2018, something quite significant happened. We had a lunar eclipse. But it wasn't just any old lunar eclipse. Something really special happened for this lunar eclipse. So we know that a lunar eclipse can only take place on a full moon. Yeah, so the synodic cycle had to align. We know that the moon was aligned for an eclipse, so the draconic cycle, which is related to eclipses, had to align. The moon was at its furthest point on the Tropic of Capricorn, so the tropical cycle aligned, and the moon was at apogee at the furthest point in its cycle. So every single one of them cycles aligned back in July 2018. And what we got is a lunar eclipse. But not just any old lunar eclipse. This is one of the longest lunar eclipses we'll probably ever see in our lifetime. Now, the only time you're going to see a full 100% full moon to the decimal point is during a lunar eclipse. When you shoot the moon 2 months after a lunar eclipse, what you'll find is the full moon only gets to like 99.9% or 99.8. Here's an example. This is a full moon shot, and it only went to 99.9. When I first caught this image, I thought if you look in the about 1 o'clock position, you see, I thought I caught a satellite. I was like, yes, got a satellite. But this is what I actually got. Yes, I'm afraid to say, no satellites. The only thing that I've ever seen pass my lens are birds, bugs, bees, and planes. That's it. To say there's 3,000, 4,000, 5,000, whatever figure they give you for satellites out there, I've never seen one in 4 years. So, back to the lunar eclipse. Yeah, so the only time you're going to see a proper 100% lunar eclipse is during eclipse, but I wanted to know, how long does the moon remain at 100% during a lunar eclipse? Because I've always wanted to see how long it lasted. So I thought I'm going to take the opportunity this time to time how long the moon remains at 100.0%. So, using mooncalc, we can probably say that mooncalc's pretty accurate, yeah? What I've showed for all my observations, it's always been accurate, and you know what I mean, I've used it to rely on my observations. So we can say it's a pretty accurate source. So the moon turned full at 100% at 15:45 on the 27th of July 2018. Now it remained full at 100.0% till 3:02 the following morning. That's 11 hours 22 minutes for a full moon. Now, you tell me any model what that would fit. You think about the heliocentric model, the moon's constantly in motion around the Earth. At what point could that moon remain full for almost half a day? It's impossible. And I'm still waiting for somebody to try and find an answer to that and give me an answer for it, because I'm still waiting. So, magnetism and gravity. This is taken from a book called, by William Hooper. It says, if either of these forces is to be done away with, it must be the mysterious, intangible, unphilosophic attraction of gravitation, which must be replaced by the philosophic and known attraction of electricity, which can be traced to a physical medium, the electromagnetic ether. So, these are my thoughts. There's been a lot of questions about how the stars work in the southern hemisphere. Yeah, does the moon rise south of the observer, set south of the observer? There's a lot of questions, and a very small minority of people have jumped on the concave bandwagon. But this is my thoughts on what's happening. So, the electromagnetic ether, what is it? We know that matter comes in three forms: liquid, solid, and gaseous. But there may be a fourth form of matter, a substance which is on the verge of being supernatural. The electromagnetic ether is a luminiferous substance for the propagation of light, and it's in a constant state of vortex motion, and it carries all the heavenly bodies according to their varying altitudes, densities, and frequencies. And it's made up of two vortices, one in the north, and one in the south. Now you put these side by side, and you can see when you're facing in one direction, it appears to rotate in one direction, and when you're facing in the other direction, it seems to rotate in the other direction. If you're on the equator, you'll just see them pass straight over your head, like that, and then they'll obviously bend off to the sides. This is an interesting time lapse. So I'm going to say that there's two wheels in the sky and not just one. So when the moon is high on the Tropic of Cancer and it appears to be circling the northern circuit, as the moon gets southern declination, it will cross the celestial equator and pick up on the ethereal currents in the opposing vortex. So what it'll be doing then, it'll appear to circle in the southern circuit. And as you can see here, for the time lapse, the moon crosses over and appears to be circling in the opposite, or the opposing vortex. And as it gets northern declination and crosses the celestial equator again, it will appear to rotating around the northern circuit. So when the moon's high on top of Cancer, if you take a time lapse, what you'll see, the moon will appear to be following the stars in the north. You take one bang on the celestial equator, whoom, travels in a perfectly straight line. Take a time lapse when the moon's low on the Tropic of Capricorn, and it'll appear to circle in this, what I call the southern circuit. Now, observing the sky is not going to affect the land beneath our feet. We know it's flat, we know there's no measurable curvature, so all I'm trying to do here is look at it from a different perspective. So, from the equator, what you'll see, you can actually see both celestial poles, the north and the south. Looks a bit like a dome as well from there, actually. There you'll see, comes round, that's the south celestial pole from the equator. And the stars will just appear to go straight over your head from there. And there you can see the north celestial pole. A bit like a giant magnet. Magnet has two poles. Yeah. Some of the currents go in one direction at the North Pole, and some of the currents go in the opposite direction in the South Pole. So for an analogy, imagine that the clock is two giant wheels in the sky. As you can see, one wheel turns one direction, and one wheel turns in the other direction. And if you put that image with the time lapse from the equator side by side, they look very similar, don't they? There you can see, you've got the stars coming overhead, but you've also got the North Pole and the South Pole. So, what you will find as well is, if you place the moon at 70 degrees north, or anywhere higher than that, on mooncalc, what you'll find is the moon's circumpolar. It's visible for 24 hours a day. But at that same time, on the southern circuit, it's not visible. It never rises. Now, we know that mooncalc's accurate. We've proved that in previous observations, in all my observations. Then when you go to 78 degrees south, guess what? The moon's circumpolar, visible for 24 hours in the south circuit. And at the same time, it never rises in the northern circuit. So for me, it's turning on one wheel, it's getting that declination, it's picking up on the current in the other wheel, and it's literally traveling what I call the lunar lemur. It's like a figure of 8. If you ever search for the word ether, you'll come across a snake will look like it's eating itself, and it looks like the figure of 8 too. So what is the moon? You know what I mean? We've been observing the moon now for thousands and thousands of years, but what is the moon's purpose? What is it there for? There must be a function for the moon. I mean, it looks like a light. Some people say, you know what I mean, it is the lesser light. It looks like a rock. Sometimes it looks like a rock in outer space. I'm thinking, it does look a bit like a rock, but sometimes it looks spherical, like a sphere. Sometimes it looks like a disc. It looks like quite a lot of things at a lot of different times. Sometimes it looks like a projection. The bright spot is actually the moon on that image, and what it did, it caused a lens flare reflection, and it created the image of the moon. That is just a lens flare. So that bright spot can create that image. Sometimes I've heard people say before, it's a hologram. It looks very much like a holographic image on that one. I caught that image myself, by the way. Sometimes it looks like it emits light. We've always said that the moon has got its own light, but you get close up onto the moon, something is causing them shadows. Some other light source and only other light source could cause them shadows. So, is it reflecting light? So, the word moon is actually derived from the word month. And the word lunatic is actually derived from the word lunar. Who's that lunatic? Oh, that's me on the streets of Liverpool doing street activism. So then, what is the moon? Like I said, we've been observing the moon for thousands and thousands of years, and we still don't know what it is. One thing I know it's not, and it's not that. That is the Discover Epic satellite, taken from 1 million miles from Earth, if you want to believe that nonsense. Rob Simon would definitely say it is Photoshop, because it has to be. So, why do I do all this? I don't do all this for the fame. I don't do all this for money. If anybody knows me, I pay my own way. I pay my own way to come here. I pay my own way to go to New Zealand. I pay my own way to go to the UK convention. Yeah. Never ask for a penny. I don't monetize channels. Yeah. So why do I do this? I do this for one reason, and the reason is the truth. Thank you.